late setup. But I'm William. This is Ohm, Kate, and Faith, and we are the capstone team working with Microsoft. For the past few months, we have been working with Microsoft in the Ag Engineering Department on a data science project to predict harvest yields. Today, we will walk you through some of the steps of our project. The big goal was using Microsoft tools to visualize the yield data we received from the Ag Engineering Department, as well as using Microsoft tools to produce machine learning models to predict yields. The beginning steps of our project involved making sense of the data. We had a very large set of data that we had to make sense and organize. Then we performed some descriptive visualizations of the data, and then made machine learning models to predict the yield. Pass it off to Ohm, who will describe this for us.
So to begin with, this is a sample of our data. So we got data for 15 years, and each one of them has this kind of data. So basically, each point on there is a yield point that's collected by the combine. So that corresponds to the output in bushels. So this is just a sample file which shows our yield data. So over to you.
All right. So this is one of our solutions to the whole unorganized dot mess problem. We took the field and we placed over it, as you can see here, this nice looking grid. Each one of these squares is roughly 20 meters by 20 meters. And then we performed some fancy wizardry in some GIS software where we were able to aggregate all the data points that were contained in each one of these squares. The mean yield, range of the yield, statistical stuff like that. And then in the end, we have a lot cleaner set of data that we can work with, and that's what we performed our visualizations on.
So here we went with equal sized boxes while gridding, because most of the data we have for most of the years is equally spaced within a row and across the rows. So that's why we went with the equal sized box. There is only 1 year data that is so irregularly spaced, whether it be swaths of the points within a given line. So that's the reason for using the equal sized box while trying to calculate the yield. And for data cleaning, we deleted few cells that has null. After gridding up the entire farm, there are some spots. Clearly, there are some spots here and there that we had to get rid of. So we just deleted them by using a filter where yield is null. And then there is another assumption we made. I mean, when it comes to the boundary between the soil types, we use just one soil type. So yeah, those are the few data cleaning things we've done. And this is the final table we got out of the entire dump we got from the Ag Engineering people. So the ID corresponds to the cell number, and that's the soil type corresponding to the cell, and that's the aggregated yield, which is basically mean. Yeah. And then we did the same thing with elevation, and that's the crop type, and that's for the that column is for the year, and those last 2 columns were added just for the visualization.
So this is one of our visualizations we performed on the data before we created any predictions. It's just a nice looking box and whisker plot. We'll run through some demos of the visualizations. This is just a screenshot, but this is very useful. The range of the elevation throughout this entire field is about 40 feet. So dividing it roughly into 17 feet chunks, I was able to categorize the elevation by whether it's low, medium, or high, relative to each other. And then performed some interesting visualizations, which we can definitely get insight here, because as you can see, a nice mid-range elevation corresponds to better yield, at least for this crop type. And then this is the same thing, but here it is just filtered by the harvest year. Before that was filtered by the crop type.
Oh, so this is one of our visuals. Faith, aren't you supposed to go first? No, it's not for me. So this is just a pivot table showing the crop type across the range of the years. So if you look at the top right, that's the range of the years. So across that range of years, these are the different crop types that were planted in that farm, and this is the word cloud representing that. So the bigger the size, the more frequently it was planted. So, and there is also, and there is also yield for each crop type for a given year. That's the one step below the year that I aggregated on. So moving on. And this is the another visualization I used to show the yield for a certain year on the Google Maps. There, each circle, each square represents the center of the yield cell that we gridded up before. And the size of the square represents the magnitude of yield in that point. So instead of having the whole cell shown there, we just represented it as a point, as we have only latitude and longitude for the center of the cell. So I mean that's the we made that because we used it because it's the simplest way to show a square cell. Instead of showing the whole cell, we use the longitude and latitude of the center of this square, and from there we used a symbol that varies in size, which corresponds to yield at that point for the entire cell. So, and the color corresponds to the soil type. So if you use the slicer to the right, you can see how it varies. You can pick your point of interest and see how it went across the years. And when you click over it, you'll get all the details in the board pad, in the bottom.
So our machine learning, so we got the data from these guys, and then with it we were able to, machine learning helps us to predict, in our case, yield. And we use Microsoft Azure for our machine learning. It was really easy to use, and it's nice because it can be automated. And here's our model for it, and we'll kind of walk through it a little bit later. So you can see we imported the data set from them first, and then we cleaned up the missing data, as Am was saying, and then we split the data into a training set and a testing set. So then we train the training set with linear regression, and then we score them against the test set, and then it predicts, and it makes a new CSV file that we can export and then visualize.
So we also made a lot of visualizations in Power BI, and for our visualization, we created a matrix, and each cell corresponds with the grid map they did in ArcGIS. And all the data points here is the mean average yield per grid cell. And the brighter the green, the better the yields are for that year. And there's also drop downs you can filter based on crop type and year. And the red spots, there was no data for because probably there's rocks or something. And we'll show that. So this is this one. You can just sort based on crop type and year. So we can go to 2004, and it'll change based on the year and crop type. Like obviously this year wasn't too good. And yeah, so if you guys want to show yours.
So first I'll start with crop history. So let's say I reduced the range to just 2003. It will show what was planted in that year. And if you want to see if you want to know which crop type produced more yield in this year range, let's say between 2006 and 2009, the bigger the font size, the bigger the yield is. Here, all of them looks comparable. I mean, we can clearly see the distinction in size here. But if I move it farther, see, corn and soy in this year range has more yield when compared to the other crop types. Oh, just a second. And if you want to see the numbers, if you look to the left here, under 2006, it's the soybeans, and that's the yield for that year. And this is just a visualization of the yield on the Google map. The big assumption here is representing this gridded up cell as a point. So that's the main basis for this visualization. So I calculated the centroid, basically, longitude and latitude for the centroid of the square cell, and I represented the centroid of each cell, not the entire square cell. So it is supposed to look like a grid, but it is laid out as a bunch of points on the Google map, because it's not feasible to calculate the longitude and latitude along the periphery of the cell and represent it like that. So here I used circles to represent the magnitude. We can change it if we want to on the right, but we can just don't think that this color coding has to do with the yield. It just represents the soil type. So if you want to look at the yield at a certain portion, you see here this circle is almost like a dot. That means it's a bad cell that doesn't have much yield. If you move further down, you see this circle. It's a little bit bigger in size, right? That means it has a better yield. So that's the main thing in this visualization. When you hover over it, it will show you all the details, latitude, longitude of that centroid, and the year we are looking at, 2009, and that's the mean yield at that point. And this is the word card that has text for it. So we are on ID 3. So this hasn't updated, but yeah. And on the side, you see this cards updating. If you click across the cells, see it changed to 37.2. And in that year, we have 2 different crop types in the same farm. That's why it changed to Pinto. Yeah. So that's it. That's all I have. Moving on. Oh, not this one.
And then we'll have one more visualization I want to demo for you guys. It's the box and whisker plot. Very basic visualization, but I think its elegance lies in its simplicity. Look at all that statistical information we can get from that. So again, we have the elevations categorized into low, medium, high, and then there's a slicer on this far end where we can actually filter these values. If we just want to look at 2010, we can do that, or we can look at 2009 and 2010 together. We get things like that. 2009 and 2014, something like this. So that is filtered by year, but also the farmer may also be interested in the same box and whisker plots, but organized by the crop type. So here we have corn that was planted, I think, 3 times out of all the years. Soy, very popular crop, so we have a lot of data from that. Of course, one of the interesting things that we can gather from just this visualization here, corn seems to grow better in the low elevation category than it does in the than does soy, which very clearly grows better in the high category there. So that's just a fun peek at our visualizations. We'll continue on here.
Alright, so some of our risks, so our field data is not yet normalized, so that's gonna kind of affect how we view it. Also, our crop type is a causal factor machine learning module, so eventually we'll want to not just rely on the crop type for that. And how we're working as a team, so we meet up weekly and we discuss what we've been working on and our goals. We are using OneDrive to share our work and to store documents such as Power BI visuals, data is in there as well. And then we test, we do peer reviews and look at each other's stuff and make sure everything's making sense. And then the things we're still working on, so we still do want to clean up some of the graph of the field in the Power BI. There's a lot of stuff you can do in Power BI. We want to include more factors such as moisture in the visuals, just so it has more factors and we can kind of play around with that. And then we want web scrape for weather data for the same reason, so we can see if like this much rain affected the crop type and kind of just get more information that way.
All right, so we have neared the end of our presentation. We just want to thank our sponsor, Dave Frostley, as well as the guys from the Ag Engineering Department, Paulo, John, Rex, and then our instructors, Alex and Dean. Thank you, guys.
Are there any questions?
So, questions about the empty cells. So, where you have null values, typically what percent is that? And then second follow-up would be if you thought about other ways to impute values as opposed to just leaving them as null. So what percent? I mean, it looked like some of the grids, there's quite a large number that the cells were empty. So do you guys have a feel for that, or?
That was just empty spots within their data, but it also corresponded with like the ArcGIS maps where there was like absolutely no yield at all.
Okay.
But yeah, some of that
So-
data is also missing, like the combine could have missed it or miscalculated there. Yeah, with the missing data, we can't do much about it because it is gone.
Yeah, I mean, you could impute based on averages of other cells
Right.
or things like that, right? To kind of, I don't know if that's useful or not, depends on what percent of the cells there are.
Right.
Yeah.
So we didn't keep track of the proportion of cells that came out now.
Yeah.
So some years are pretty much good. I mean, and some years has nulls in that ditch we have running across the farm.
Right, that could be a little.
Yeah,
smaller.
so I mean that can be done. I mean, we didn't focus on it in the
Yeah, and
results.
that's what you have to understand, what's going on behind the scenes, because it could be a slew or something, so you're not
Yeah.
legitimately not getting data. Other cases, it could be an equipment failure, and that John would probably
Oh yeah.
have some good insight into that, so.
So that's why we didn't use 2015 because the data, is not, it's funky like how it is paged and all. So,
I have a question. Not a question, just wondering, what was the biggest problem you had with this, or biggest concern, or what didn't work? What problems did you have with the data?
Oh, the main thing I would say is not having causal factors corresponding to the cell level, at the cell level, That's, we basically have to look it up for every cell. So, I mean, there are some factors that we can deduce based upon the location of the cell, like elevation, crop type, and not the real causal factors though, like, that's the main challenge, collecting data. And I know that you guys are trying to implement those kits or whatever to collect data, so that's the missing part, I would say.
If you have any desire to visit with the farmers? Jeremy and Sarah, they'd be happy to communicate with you. So if you have any questions that don't make sense.
Oh, yeah, we need few inputs now. Now, at this point, we want to know the growing season length for each crop type and the planting date and when it will flower. Obviously, they won't line up right across the prospects. So we want to break it up into 3 periods so that we can find the average. So we need some business knowledge there. So I spoke with Paolo. He actually helped me a lot from the starting. Without him, I wouldn't have done anything. So
You're doing well.
yeah, I spoke with Paolo, and he told me to contact you at some point. Yeah, so.
Well, I have a question about machine learning. So about testing and training samples. So what's the portion of your training and testing?
So first off, we don't have data ready. All the causal factors in the table, X's, we don't have them ready. For records, we have 20,000 training data. If we're gonna use it as a whole, yeah. So we are not clear yet on how we're gonna run our model.
Currently, in the model that we presented today is 50-50, so 50% of the data is
being trained, and then the other 50 is being scored again. So.
So I saw you guys using a linear.
Yep.
Model.
Oh,
training the machine.
those are mock-up models. We didn't get into the details, you know. Look, it doesn't have all the attributes yet.
We tried a different few things to test it for.
Yeah.
We found that linear regression was the most accurate to what yields were predicted. So that's why we went with linear regression.
I was going to mention if you try the other.
Yeah, we tried the other ones, and they were off by kind of a lot. And I think we were only off by a few on the linear regression. So.
Yeah, we tried neural network and a tree-based algorithm as well.
Yep.
One of the goals is to evaluate the tools. So
Oh, yeah.
do you have feedback
Yes.
related to those yet?
Yes. We are keeping track. So far, we used ML Studio and Power BI. There are a lot of problems with Power BI service. I tried to create dashboards, and it's not working well for me. Maybe it's just me. But I'm trying to discuss it with Dave whenever it's possible.
For me,
So-
like the learning curve of both Azure and Power BI was really easy and simple to use. I had no
Yeah.
issues at all.
Yeah, I thought Power BI was great with visuals. As you saw, there was a lot of different visuals you could do with the data, so it wasn't bad.
Yeah, my experience with Power BI was very good. Yeah, I haven't worked with Power BI service, so I'm not exactly sure how like the cloud integration part of it kind of works. But working with data locally and saving visualizations locally, I've had no problem. And very intuitive, easy to use.
Yeah, ML Studio documentation is not so intuitive for me.
I guess maybe it's more of a limitation with Google Map, but just especially when you have that many different soil types where you get basically a rainbow of dots, even just looking at it is kind of not immediately intuitive. And I don't know if there's anything you can do with Google Maps, but I just don't get a feel like I can look at that and glean any useful information immediately. Maybe, I don't know if there's a way to build a visualization that you can just overlay on top of the map, where it's some image that you've produced and it's not scalable, but it's more representative of what someone might want to see.
Yeah, I mean, we can always, there are only so many options in Power BI for us to, play combinations with. So one thing is, it's just basically 2 options. I have to choose either color or magnitude while showing it on the Google map.
So one related question to that is, you guys settled on the 20 by 20 But just looking at the visuals, there looks like to be a fair amount of difference in yield between adjacent cells, which seems a little surprising to me. But maybe that's just what I'm seeing. But did you guys think how did you arrive at 20 by 20 as opposed to something larger or?
Well, that's basically arbitrary. So it's that we choose it such that I mean we started with the box that entails the whole farm, and we tried to get the box to capture. It's a trial and error thing for us, so we just went with what seemed reasonable at that point. I can discuss it later if it needs some detailed explanation.
Just one thing to say about the topic of grid cell size is that I've seen in other projects people use for their grid cells the width of the combine harvester, and it's much more makes a lot more sense to a farmer who looks at the map, because the cell size correlates with each swath of the combine.
Yeah, it's fine if they do it the same way every year. Yeah.
And then
the
so
problem.
the resize the length of the field? Oh.
No, it's
Yeah.
still split into segments.
Okay, so it's the width of the combine and then some.
Yeah, in order to build the model, we need to be done it. I mean, he has to do it the same way every year,
Oh, yeah.
which is not possible.
I understand.
Any more questions?
Thank you.
Thank you.
Thank you.